Next talk will be by Siddhartha. He is the writer at Playful Python and the author of Test-Driven Python Development. Today he'll talk about the topic of supercharge your Python code with the match statement. So welcome, Siddhartha.
Thank you, Ritesh. And can you all hear me? No. I'm using this. All right, so to start with, I just want to take a quick poll here, right? How many of you have used the match statement in your code? Can you raise your hand up? Okay, 1, 2, 3, 4. And how many of you have heard about match statement but have not used it? Okay, a little more, right? About 10. Cool. So today we're going to take a look at this match statement, right? What it is and how to use it. Now, there's been a lot of this is one of the popular features which was released in Python 3.10, which actually didn't become so popular. Not a lot of people know about it or use it, but I really like it. So I thought, okay, I've got to talk about this and make people see why it's so awesome so that more people use it, right? So that's the theme of my talk. Okay, we can skip this, right? So match statement actually came in Python 3.10. So it's been quite a while, right? 3.13 is going to come out next month. So it's 3 years, and not a lot of people, like I said, have been using match statement. And when I first, saw match statement, I was also in that crowd which did not like match statement. I said, why do we need match statement in Python? And when I went online and took a look, there were a lot of examples like this. And this is an example where what this code does basically is you have a variable direction, and depending on the value of the direction, like north, south, east, west, it will execute or return that calculation which is there below, right? And a lot of tutorials on the internet were like, oh, now switch case statement comes to Python, right? This looks like switch case, right? How many of you use switch case in any other language? Okay, almost everyone, right? So this looks like switch case statement, and people were like, oh, now Python has got switch case. For many years, right, people have been asking for switch case, and Python has not been, it's not been added to Python. And a lot of people used to say, yeah, we can just use if, else, if, right? Why do we need switch case? Then finally match statement came, and a lot of people were like, okay, switch case has come to Python. And, for so many years, even I used to say, why do we need switch case? We can use if, else, if. Is this really such a big improvement over saying if direction equal to north, then return, else if direction equal to south? It's hardly any difference, right? Do I need a full feature in Python just to make my if else little better? So I was also in that category where, yeah, I don't like match. I don't want to really use match, right? Then later on, I came across this term. Yeah, you go to Google and all in those days, it will come, what is a switch statement? Then later on I came across this term. See, with Python 3.10, when they released it, they had this picture over there with all the new features over there, right? Context matcher, better typing syntax. And the bottom over there was one thing, structural pattern matching. Okay, and I was thinking, oh, what is this structural pattern matching? Like such a hi-fi word for putting switch case, right? And then I thought, okay, let me explore structural pattern matching some more. And then when I started exploring that, I really understood, okay, this is what the match statement is all about, right? It is actually nothing to do with switch case. Right? The code which I showed looks like switch case, but actually it is nothing to do with switch case. It is everything to do with this feature, structural pattern matching. But it's a little technical kind of sounding term, so a lot of us kind of just ignored it. So what I'm going to do today is we'll take a look at understanding what is structural pattern matching, right? And then we'll start looking at some regular use cases of this. Now, if you go to that PEP where the structural pattern matching is defined, Python generally has really good documentation and all that. But I feel this is one place where they drop the ball. Because if you go to that PEP, and in all these PEPs, they have examples, right? Why would we want this feature and all that? And you have to make a case, then only the PEP gets accepted and implemented. So there, all the examples are, hey, this will be really useful if we are writing a parser or we are writing a compiler, right? And all the examples are like, this is how it can make our compiler better. Right? Okay, let me just do another show of hands. How many people here are writing a compiler? One, right? Cool. And how many are writing a parser? Okay, same one plus 1, 2, 3, right? And so, even I thought, hey, I'm not writing a compiler. I'm not writing a parser. Why do I need this, right? And so that's where I feel like, even in the examples, yeah, writing a compiler or parser makes heavy use of this, right? But what about normal use case which you and I have, right? So we'll take a look at some of those normal use cases which you and I work with, which have nothing to do with compilers, right? Okay, so first we'll try to look at what is structural pattern matching, and then we'll look at some use cases. That's basically what this session is at a high level. All right. Okay, so before we start, right, I want to also talk a little bit about other kind of pattern matching. Have you heard of any other type of pattern matching apart from structural pattern matching? Regex, right? I heard a lot of people say regex. So regex is an example of a pattern matching, but that is pattern matching in a string, right? So I've got a string, I've got some pattern which I want to match, and what regex does is, it's kind of like a language, right? What it does is it goes to the string and whatever matches that pattern, and you can find out whether something matched the pattern or not, right? True or false. And you can also extract something from the string, right? I want some part of the string. In that pattern language, you can extract and get something out of it, right? So just keep in mind these two things. One is checking whether a pattern matches or not. Second thing is extracting from the source some value what you want, right? Now regex matches in a string, okay? But here structural pattern matching is, the concept is similar, but it's got nothing to do with strings. We're going to match on the structure, okay? And just like regex, where we have a kind of syntax for describing the pattern, right? Even here in structural pattern matching, we have a syntax for describing the pattern. So just keep these three concepts in mind. We have a pattern, we have some data, and we're going to first match whether it matches the pattern or not, and secondly have some way of extracting the data from the pattern. So here we've got an example. Can you all read from the back? Yeah. Okay. So here's this is just a dummy code, right? And what this does is, imagine you have some API, right? So I've got here a call to an API, and this function, it returns two things. If it's a success, it's going to return a tuple with OK and some value, right? From the response, it's going to put some value. But if there's an error, it's going to return error and the status code, right? So we have a tuple. The first element of the tuple will be error or not error, and second element depends on what it is. So if it's no error, it will have some value. If it is an error, it will have some status code, error message, whatever. Now, I have a call to that function, right? So here we are calling that function. And now, depending whether it is an error or not, we need to handle it differently, right? So now the first element tells whether it's an error or not, right? So we check if it is okay, then we do something. Here we extract the second value and put it in a print, else we do something else. Now this code is not really that readable, right? Why is it not readable? Firstly, imagine that, this code is, this get user ID is in some other file, right? I can't see it. I'm just reading this code over here. So if I'm just reading this code over here, what is value of 0? I don't know. Right? Only if I have to go to that function and see what is it returning in that first spot, then only I know what is value of 0. Right? Here I cannot directly make it out. Same way over here, what is value of 1? I don't know. Right? So that is one real problem from a readability perspective. Now we can kind of solve that by changing this, right? We can get, say, status comma value is equal to this, and then I can put, so that first line above, it will split up the tuple, it will Yeah, the first line, it will unpack the tuple, right? And so the two tuple, it's a two tuple, right? That will put status as the first value, the value as the second value. So from a readability perspective, this is better. Now at least I know that the first item is a status, second item is a value, right? But even here, it's not really clear because in the success case, the value is some ID, right? In the failure case, that value is a status code, right? They're both two different values based on, what is the first value. So this thing makes it a little better readable, but really not that great readable, right? So what are we doing here? Firstly, I want to know whether the first item is okay or error, right? Based on that. So I want a pattern. If it's a tuple where the first item is okay, then there is one flow. If it's a tuple where the first item is error, then there's another flow, okay? Secondly, I need the second item. In the first flow, the second item is an ID. I want to get that ID and print it over there. Or if it's an error, I want to get the error code and print it over there, right? So these are the two things which I want to do. So now let us look at another code, which will do the same thing with match, right? So here's the same code with match. So here we say match and we make the function call, okay, and we get some data. And now what we have in the case is the structural pattern matching. So inside the case, we are giving the pattern, right? So over here, the case says, is it a tuple, okay? And also the first item of the tuple, is it okay? Okay, so now that's our pattern. Okay, and here you can see why it is called structural pattern matching. We are matching the structure of the data. Is it this kind of a tuple, right? That's what we are checking here. So that's our pattern. And then the second case says, is it a tuple? And is the first element of a tuple is an error. So if it matches that pattern, then it will execute that block, right? Now, what's the next thing we want? Now, next thing is I want that value, right? In the first block, I want the ID. In the second block, I want the error, right? And we see here, we've given a variable there, okay, comma, ID. Okay, so here, that ID will again be matched to the pattern. So just like in regex, you can give brackets, something, and whatever matches to that will be extracted as a value, right? So here, whatever is the second item of the tuple will be extracted as a value and put into the variable ID. Okay, so in that print statement over there, I can use that variable ID. Okay, so that value of that ID is whatever is in the second spot of the tuple. And same way for the other one, right? We have error, comma, error code. So again, it's going to match the pattern. Is it a tuple? Is the first element error? If it is true, then it is going to extract the second element to that error code variable and execute the block, right? And I can use that variable over there. So what do you think? Do you all like this code or the previous one? Who all like this code? Okay, everyone, almost. Okay, so some of you like the previous one. All right. So this is a simple example, right, where I have a tuple, but that tuple can have two forms, and I need to check what form is the tuple. Accordingly, I want to do something, right? So that's the idea of structural pattern matching. We have data. That data is in some form. We want to check, is the data matching to this kind of pattern? Then do something. Is it matching to some other kind of pattern? Do something else, right? That's the idea of this. Okay, let's take another example, right? So many times we have these GraphQL APIs, right? So let's see here. Okay, so here, so here we have an API, right? So I made an API call. Now this is an example of a GraphQL API. In a GraphQL API, the data which is returned, will have some format. This is taken from the GraphQL side. On the left is a success response, right? I've done the API, I got some data. So in GraphQL, it will have a data block, and inside that will be whatever is the response. right? And on the right hand side is an error response. So when there's some error, GraphQL will return a JSON like that, which does not have a data block. It will have an errors block, and inside will be list of errors, right? So I have a code, I made an API, and now I want to process the response. Now left, it could be a success response, it could be a error. Now imagine I've made it all into Python dictionaries, right? But now I need to analyze. If I just directly go to data, hero, name, right? But what if it's an error? Then all those will fail. I'll get key errors, right? Because that data itself is not there. So I need to handle all those key errors. First, I need to check is data there. Inside that is hero there. Inside that is name is there. Then I can take that value and use it, right? And same way, I need to handle the errors. And for that, it is going to have an error key and inside that some data, right? So now I need to handle both these formats. So normally, this code will be like lot of if, else, try, except will be there for each and everything in this till I get that value what I want. And it's also possible, sometimes the response could be invalid. So it should either be data or error. One of those have to be there. But if something is wrong with the API and I get something else which is not data, not error, my code should handle that. Right? Okay, so generally it will be a lot of very messy code. Right? Now, if we look at pattern matching, right? Here's what the code will be with pattern matching. So we are saying, is it a dictionary? So we've got match the response, and we say case, and then is it a dictionary, and does it have the errors key? Okay, so if it's a dictionary which is having the errors key, then execute that block. Not only that, if it is having the errors key, then colon, I've put a variable there, meaning whatever is the value of the errors key, extract that into the errors variable. Right? So after matching the pattern, I don't need to access it. Whatever is there inside the errors, that list over there, right, is automatically extracted into the variable. And I can put a for loop and print it out. And same way, now what I want is the name, right? So is it a dictionary which has a data, and inside that it has a hero, and inside that it has a name? If it is matching like that pattern, then extract me the value of the name key, which is in that inside spot, and then execute that block, right? So here we can see how simple it is. Is it matching this pattern? Do something. Is it matching this pattern? Do something. And later on, I can have one more case if it is none of them, right? Like a default case. Or something went wrong, it is none of them. Then what should I do? I can put one more case there to handle that condition also. Right? So you can see how this code is very simple, very elegant, right? Instead of having if, else, try, catch, this key is there, that key is not there, and trying to handle all that, straight away you can just say, okay, is it this structure? Then do this. Is it this structure? Then do this. Right? So this is an example, like APIs is a common thing which we always keep working with, right? And we need to be able to handle, and API is like pretty much unstructured. The server can send anything in any format, right? So this is a really good fit for that. Now in pattern matching, we can also do some more things, right? So here's a kind of case you can do like this. So here we are saying, is it matching data, and inside that hero and inside that hero friends, right? Just like what we were doing before. But after matching it, we are saying extract the value into friends. So it goes and extracts the value into friends. And then we can put a guard. So all of you are familiar with list comprehensions, right? List comprehensions has this ability to put a guard at the end, right? For this thing in this, if, and then you can put a condition there. Right? So you can do a similar kind of guard even with the pattern. So the guard is executed after extracting. So it matches the pattern, okay? You extracted the value, and then you want to put some check on the value. So here we are checking that none of the friends is none, right? If that everything matches, then it will execute the block, right? So here in this example, right, let me just run this. Okay, right now, this is the response which we saw before. So it has gone to the second case, right? And it has printed out the things there. Now I'm going to put a none in the middle. Right, so this is the dummy data which we are using, right? So what it has done, it has extracted the hero's friends, right? And these two got printed out over there. Now I'm going to put in the middle a none. Okay, and now let's run it, right? So now what has happened is, because I put a none there, so that if none not in friends, that guard clause is no longer valid, right? It fails the guard. And so it skips that pattern. It matched the pattern, right? But then after extracting, it failed the guard. And so it comes down to the third section over there. And here again, it checks the patterns from top to bottom. So it's possible that, multiple patterns may match. So in this case, both the second and third patterns will match. But since it's doing from top to bottom, right, the guard, that one will be checked first, the guard will fail, then it will come to the third one. Right? So this is basically at a very high level, what is structural pattern matching, right? So with regex, whenever we have a different structure, right, we can do this pattern matching. So now what I'll do is I'll just go through some examples, right? The PEP has a lot of examples on like what all kind of structures can be matched and all that, right? But I'll just go through a couple of simple examples. There are many complicated examples also, but I'll just go through some simple ones. So here's an example. I have a data class and it has two values, x and y. And I created an object, right? P is equal to 0.0, 10. Now here in match P, I can tell like is what kind of value. So if it is point having 0, 0, so x and y both are 0, then it will go to that block. If in the second one, y is 0, right, but the x value is non-zero, right? So then what it's going to do, it's going to extract the value to the variable, right? So this should be, right? So x is 0, but y is non-zero, right? So then it will extract the value of y to that variable and we can use it in the block. The third one is y is 0, but x is non-zero. So it will extract the x value to the variable and we can use it. And in the fourth one is the default case, right? It did not match any of the other ones. Then it comes to the fourth where it extracts both the x and y to the variables and we can use it. So here's an example where we have a data class, right? It's a custom class which we created and we can still do pattern matching on that as well, right? So it's not only for lists and dictionaries and things like that. Another cool use case is here I have two separate classes altogether. So imagine I have an e-commerce store. I'm selling both games and books on that store. Now games has got some separate fields, books has got some separate fields, right? But here I have a cart, I have a shopping cart. It has got some game objects in it and some book objects in it, both of which are separate fields, and I want to process them, right? So I want to process them differently, extracting certain fields in case it's a game, in case it's a book, right? So you can do it like this. You say case book of, and then whatever fields you want to extract and use it, and case game and whatever fields you want to extract, and you can use it. So normally here we have to put an is instance and do all those kind of things, right? That's not required. With the pattern matching syntax, you just put this. So internally Python will still do all those is instance and all those things, right? But we don't have to try that code. We can just put it. Is it a book? Then I want these fields. Is it a game? I want these fields, right? And then use it directly in the block. So we can also use it when we are having a structure which has got different data types, right? And generally in code, we don't, using is instance is not so common, right? Generally you will try to create an item class which kind of joins both game and book into common fields and makes subclasses. That's how we generally write the code, because it's such a headache to do this. But with pattern matching, we don't need to do that. We don't need to create an item and inherit book and inherit game and do all that. We can just create those classes directly, create those objects, put them all in the list, and just pattern match it on that. Right, so this is another example. And finally, one last example, right, and then we can go for questions and all that. So here's a common example where when you studied algorithms in class, probably reversing a list, they would have done it like this, right? If the list is empty, the reverse is empty. If the list is not empty, then take the first item, put it at the end, and reverse everything else. So here, normally we code this in Python, right? You can code this with if else. It's not a big deal, right? You can check if list is equal to empty list, right? But you can do the same thing even with pattern matching. So case empty list, then do something, and case non-empty list, right? So in a non-empty list, we can again extract. So it did not match the first pattern, so it's obviously a non-empty list. Then we can now extract. So the first element and the star rest means everything else, right? So that's how the pattern works. So the first element will go into that variable first. Everything else will become a list, and it will go into the variable rest. Right? And then we can return. We put the first at the end, and we reverse all the rest, right? So this will basically reverse a list. So we can see here that the syntax of what kind of pattern to match and all can go more complicated also, and the code also becomes quite simple, right? So now one common question a lot of people ask is, I can do this with if else. I can say if list equal to square bracket, right? Do I need this? So my answer to that is, right, let's take list comprehension as an example. How many of you like list comprehension? Yeah, put your hand up. Okay, almost everyone, right? This is a very popular feature in Python. Now the thing is, everything I do in list comprehension, I can do with for loop, right? Agree? Right. So why do you like list comprehension? Readability, right? It's very elegant, it's readable. And the thing about list comprehension is it expresses the intent, right? The idea of list comprehension is to create a new list, right? That's the whole idea. It's not like a generic for loop. And even a for loop, you can do everything in a for loop with a while loop, right? So while languages have while loop, for loop, list comprehension, if you just have while loop, you can do everything, right? But the thing is, each thing expresses a certain intent for the person who's reading the code. When I have a while loop, it could be anything, right? When I have a for loop, it expresses the intent of iteration, right? But it could be any kind of iteration. I can have a print inside, right? When I have a list comprehension, it expresses the intent of creating a new list, right? So languages have different features which expresses different intent, even if it can be done with something else. So for me, if condition is like, it's generic. You can put whatever you want in the if, right? It doesn't have to be about matching a pattern. It could be checking various things, and I can have very complicated ifs. Whereas pattern matching, structural pattern matching has a very clear intent that it is for matching a certain kind of pattern, right? So whatever you do with pattern matching, you can do with if. I can do if is instance of, I can do checking all those things myself with the if condition, right? But it will be more verbose and inelegant, right? And it doesn't express the intent. When someone sees a match statement, they directly know, okay, I have ABCD patterns which I want to match, right? So that is the whole idea. So if you feel like everything I can do with match, I can also do with if, right? My response is match kind of expresses that intent, right? Whereas if is generic, there could be anything in there. Okay, one final thing to look out for, right? Take a look at this case. This actually will give a compilation error, right? And the reason for this is, what does this do? you think it is matching those strings, right? So keep this in mind. Whatever is inside the case is a special syntax for pattern matching. It's not regular Python, right? So even in the previous example here, right, case point of 0, 0, it doesn't mean it will create a point object and compare, right? It's just expressing the pattern. Okay, so here when we have this north over there, right, that's actually a name, valid variable name, right? So what it is going to do, it will match everything and assign the value north to that. It will extract the whole thing into the variable north, right? So that's just the one thing to take care of. You'll get like this kind of error if you do that, right? But apart from that, that's pretty much it, right? Yeah, thank you. Yeah, sure.